Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Cold, dilute, alkaline KMnO4, Bayer's reagent, is a mild oxidizing agent that reacts with alkenes via SYN-dihydroxylthione, adding two OH groups to the double bond carbons in a cis-SYN fashion without breaking the carbon-carbon bond. Moving on to the next step. Identify the substrate. 2-butene is CH3, CH is equal to CH, CH3. The double bond is between C2 and C3. Moving on to the next step. Apply the reaction conditions. Cold alkaline KMnO4 performs SYN-dihydroxylthione across the C2 is equal to C3 double bond, adding an OH group to each of the two carbons of the double bond. And for the final step, determine the product. Adding OH to C2 and OH to C3 of 2-butene gives CH3CH, OH CH, OH CH3, which is 2,3-butanediol, a vicinal diol glycol. This corresponds to option D. Why other options fail? A. Butanol, an aldehyde, would result from ozonolysis, O3 followed by reductive workup, or from oxidative cleavage conditions, not cold alkaline KMnO4. B. Butan 2-1, a ketone, would also result from oxidative cleavage or Wacker oxidation, not from cold alkaline KMnO4 dihydroxylthione. C. An epoxide is formed by reaction with a peracid, example, MCPBA, not with cold alkaline KMnO4. Cold alkaline KMnO4 is specifically known as Bayer's reagent and its hallmark reaction is the formation of vicinal diols from alkenes. Therefore, the correct answer is D. Therefore, the correct answer is option D.